Lesson 8.2. We are going to start to add and subtract. Rational expressions, but first we must warm up. We don't want to strain any math muscles. Okay. Anybody remember what we call this?
Complex.
Complex fraction. Fraction within another fraction. All right, when I have a complex fraction, and we talked about how every fraction is really just a division problem, we would treat this as my numerator, which is that rational piece 3x squared plus 13x plus 4 over x squared minus 4. We could rewrite this as a division problem. Divided by...
X plus 2 over 4.
No, you don't flip it when I'm just writing the division problem. Hold on, you're one step ahead of me. This is what this problem says. Okay? Now, you're right. In order to divide, we do the keep, change, flip. So that's what I'm going to do next. But I do want to point out, like, this is the exact same math as that complex fraction. Saying this divided by this. So in our process with division, yes, we change it to times reciprocal. So we keep the first fraction, change the sign, flip the second fraction. What do we do next?
Factor.
Factor, one of my favorite F words.
Nope.
Factor. This top, you should have factored to 3x plus 1, x plus 4. And I had to use AC method off to the side.
Yeah, wait, what? Yeah. Oh,
I got.
Yeah, wait.
Oh,
Can't do that.
I forgot to. Yeah.
Can't do that. Can't cross off these 4s.
Wait a minute.
They have to be factors.
What'd you get, Wesley?
I got 3x plus 4 and x plus 1.
I got 3x plus 1.
Yeah.
And
Wesley did it wrong.
Okay,
Sorry.
let's go over the AC method. 3 times 4. Two numbers that multiply to 12 and add a 13 are 12 and 1.
I just missed a step.
Oh yeah, I definitely did.
Yeah, but that's important. You can't cancel with division or with addition and subtraction. Split in half, factor by grouping. Okay. That would be how we factor that. Factor first. Don't do the fun canceling out stuff until everything's factored. All right. X squared minus 4 is a difference of squares. X plus 2, x minus 2. X plus 2, nothing I can factor out. Here I could factor out a 4. If it helps you too, sometimes my previous students, like when they notice that there's nothing that can be like factored, especially out of here, they'll like just put parentheses around it to like remind themselves like there's nothing to be factored, but it is a factor. Okay. All right, now we get to do the fun part where we get to cancel stuff out. All right, somebody just shout out one common factor.
X plus 2.
X plus 2. Another one?
X plus 1.
X plus 4. Those should have been the only things you canceled out. So our final answer we would write as 3x plus 1 over. Now, when I do x minus 2 times 4, typically see that 4 out in front. That would be the best way to write that answer. And again, you don't have to redistribute that 4 through. How many of you guys got that one correct?
Me? No, I did not.
I did.
Air fives. Okay.
Let's look at the air 5. You got it wrong.
You guys ready now to add and subtract?
Nope.
Yeah, sure. Pretty
Yes.
We'll see.
All
Alright, first let's see if you know how to add and subtract fractions.
Oh, I don't want to do this.
Okay, no calculators.
What? Willis, what are you doing?
Come on, Wesley.
Okay.
It's not.
So much
Alright.
easier.
Try it. I'm just going to give you like 1 minute so you can know how to add these fractions together.
If I can do
I'm just gonna look to the next page.
try.
Let's go. So 3, 2, 1, go.
Chicken rice.
Hmm?
Chicken rice.
Yes, sir.
Yeah.
Wait, no, wait. I have rice, but no chicken. It's cold.
Oh, chicken. What about chicken and rice?
Like the best lunch ever.
So we were trying to add fractions.
Yeah. I already added French. Actually, I'm subtracting.
Okay, or subtract. Okay. What is like the main thing we need in order to do this? Nick?
Common denominators.
Common denominators, right?
No.
We do not just add the numerators, add the denominators. Whoosh. Yes. We need common
Do that
denominators.
After you get done common denominators.
We don't even do that. We don't add the denominators together.
Well, yeah, but same thing.
So, what's the LCD? Do you guys know what that stands for?
Least common denominator.
These are so smart. What's the least common denominator in number 1? 10. The smallest multiple that both of those numbers go into, right? 10. Do you know how to make equivalent fractions?
No.
Times the top and bottom, as long as you do to both, by whatever you need to get that LCD. So I'm creating an equivalent fraction. And again, the only reason why I'm like doing this step by step is because this is exactly how we do it with variables, okay? So here I times the top and bottom by 2 because that's what was missing for my LCD. Here it already has my LCD. And then we can add the numerators. Do we add the denominators?
No.
No, keep the denominators the same. Just 1 for 1. All right,
I got it.
10 and 30. What would my LCD be? Or I just said the answer.
Ooh,
Dang it. Oh. 10 and 3 is 30.
I got it.
All right, so my first fraction, what I need to times the top and bottom by?
7.
Yeah.
7. 3. Ooh, good thing you're going over this. 21. Second fraction's missing a factor of 10 from my LCD. Here you should have gotten 11 over 30.
Oh boy, how did I mess up?
All right, 2 and 8 LCD.
8.
8. Could we change them both to 16?
Yeah, but 8's easier.
Yeah, we want to pick the least because then it's less simplifying you have to do in the end. So 8, and then I don't even have to change this fraction. Here I'd have to times the top and bottom by 4. Why can I do this? Why can I times the top and bottom by 4?
Because.
It's still the same fraction. If you do it both in the top.
Exactly. As long as you're to the top and the bottom, you're really just multiplying by what?
1.
1, right? You're really just multiplying by a 1, okay? And as Nick said, we all know 4/8 is the same as 1/2, so we're good. All right, this one 5/8.
5 I got that.
Okay, this is probably the most challenging. LCD between 6 and 4.
Oh, 12.
12. Good job,
I
class.
got it.
12. 22 and 12.
22, 12. Not 9. 12.
13.
13, 12. Thank you. Almost did that math. 13, 12.
So I got it.
13, 12. 4 for 4. Good job.
Manchester.
All right, so
5 for 5.
this is just a little screenshot out of your textbook as to how we do this with variables. But if you understand the process with numbers, it's the exact same. To add and to subtract, we need to first find an LCD, rewrite each expression with the LCD like I did in my second step there, and then we add the numerators, keep the denominator same, or subtract if that's the operation they're asking us to do. Okay? Probably the trickiest part for students is finding the LCD. So we're just going to kind of practice that first, and then we'll actually try some fraction ones, okay? So LCD, you guys all told me that stands for least common denominator. So when we throw in algebra here, the LCD is just the product of all the factors to the highest power that they occur. All right? So really when you're finding the least common denominator, you're finding the least common multiple of the two numbers. And there's some in your homework that are phrased this way, like least common multiple. And once you add it as a fraction, once you create a fraction with it, now it's just the least common denominator, okay? So for example, if I said, what's the least common multiple of 6 and 4, you'd all tell me 12. But if I said, what's the least common denominator of these fractions, you'd still tell me 12, because you're really just finding the least common multiple of the denominators, right? Okay, that's just a little vocab review for you. So here, once I start to throw in variables, the easiest way I think to do this is to kind of think of like the factors. Okay, now obviously we're gonna get to some like these ones where you actually have to factor it. But in this first example, let's start with something simple. So I kind of like to break down, I mean, you might not know, I have to find the least common multiple of these two things. You might not know what number is the smallest that 15, 16, and 20 all go into off the top of your head, right? What?
1.
No, not factor, multiple. Least common multiple.
Yeah, 1.
That's not a multiple.
It is.
Multiples of 15 are 15, 30, 45, 60. Like count bys, those are multiples.
Oh.
Yeah, we're not doing greatest common factor.
Oh, okay.
Greatest common factor is different. Okay, good, that's right. Multiples of 20, 40, 60, 80. So you have to find a multiple
Oh boy.
that all three of those go into, right? And when you get to big numbers, it can kind of get confusing. So think of like the factors of 15 or ways you can break down 15. So I'm like, okay, I could break down 15 as 5 times 3, 16, 4 times 4. I could keep breaking that up if I want, but this is kind of how I start it, is I kind of just think of the factors. Do you guys remember doing this in like 6th grade math?
Yeah.
No.
I love doing LCM and GCF. All right. So I see here that 15 contains a factor of 5, right? So that means in my LCM has to contain a factor of 5. So I kind of just cross that off like, okay, that is represented in my LCM. You can't like take factors away. Yep, you could cross out this. You're like, okay, we got that 5 represented in my LCM. Okay, that's right. Next, I see I have a factor of 3. So I'm like, okay, I need at least a factor of 3. And there will give me a multiple of 15, obviously, right? Okay, now, I like that we cross off this one already too. So now I kind of need a multiple of 20 represented in there. So let's jump over to 20. This one's being times by 4. So I need to multiply in a times 4. And here's where I'm going to get that multiple of 20, right? Now to get the least, we don't want to add in, or I should say multiply in more factors than we need to. Okay, so I'll kind of explain this when we're done here. So when we get to the 16, see how 16 has 2 factors of 4?
Yep.
Right now I have 1 factor of 4, so I could be like, okay, I already have this represented in my LCM, but do I have another 4 times 4? No, I don't. So when you think you're done, you should be able to see all of these factors represented yet shared in your LCM. Okay, so here's how I'm going to do that. So do we have that factor 5 times 3? Yep, that's right here. Do we have this 4 times 4? Yep, that's right here.
It's 4 times 5.
Do we have the 4? Oh, gosh. I kept doing that in my second hour class too. 4 times 5, thank you. Do I have the 4 times 5? Yes, I do, right here. And you can share them and you want to, and that's what's going to give you the least. Now, do you kind of remember doing this in the...
Nope.
No. Oh, boy.
I definitely didn't do
In
this.
6th grade? Maybe early.
I think you only had like 2 numbers.
Honestly, maybe earlier. Yeah. Okay. So when you do multiply that number, you get 240.
I didn't do it like this.
You probably did like, you can do it by doing like factor trees and prime factorizations.
What are factor trees?
Factor trees is where you like do this. And you break down 4.
Yeah, I remember
So the
doing
prime
that.
factorization is, yeah, that's usually how you do LCMs, and then you kind of like build it off of your LCMs. All right, anyways, you won't have to do too big of numbers. We're going to more do like ones like this, like algebra ones, okay? So now let's look at variables. Variables are actually easier because you don't have to think of like how many factors of A are there in each of these. They tell you how many factors of A are right here. 2. So we at least need 2 factors of A. All right, let's just go down my list here. 16 doesn't have any factors of A. Okay, so I don't need to multiply any more in. My third term has how many? 3. So the least amount that they all have is 3, right? Pretty much, yep. The least amount they all have. That's what a least common multiple is.
Wait,
Okay.
why did you only put 1A when there's 3?
Bro.
8. I just did 8 times 8 times 8, which is 8 cubed.
But there's 2 over there.
2 here and 3 here.
Yeah.
So what's the least number that they both have?
3.
Mm-hmm. It's okay. We'll do another one. B. How many do I have here?
1,
How many do I have here?
5.
5 and none.
5 B's.
So we need 5 B's. Yep.
Oh.
So Connor said yes. You pretty much just take the largest amount, if that makes sense to you. All right. How many C's do I need in my LCM?
6.
6. Yep. So there's my least common multiple. That's a number that all 3 of those terms would go into. Okay, that's the way to think of it. All right, so let's try one with now fractions. This is actually easier. Find the LCD of the rational expression. So that's just a fancy way of saying find the least common multiple of these 3 denominators. All right, so with these, it extremely helps if you factor. You're going to want to factor. So kind of like we did here, we kind of factor, broke it up so we could see this. When you get to algebraic expressions, you want to factor first. Okay, factor first. So this is a trinomial with a 1 in front. We like those. 2 numbers that multiply to positive 1 add to negative 2.
-1, -1. Yeah.
Okay, those are the factors of that trinomial, that denominator.
Mm-hmm.
All right, let's move on to my second fraction. What can I factor out there? 5. So my second fraction has 2 factors in the denominator. It has a factor of 5 and a factor of x plus 1. All right? Third fraction, x squared minus 1. Does that factor?
Yes.
Yeah, x plus 1.
X minus 1.
Good, difference of squares. Okay, so to find my LCD, all my factors have to be represented in my LCD, and I want to share as many factors as I can, just like I did with the numbers up here. All right, so I just started my first fraction, and I see, hey, this one has 2 factors of x minus 1. So I'm going to have 2 factors of x minus 1 in my LCD, and if you want to write it like this, you can. I'm okay with that. That's how I do it. All right, because I can't really take factors away. I can multiply more in to make common denominators, just like with numbers, right?
Oh, and then get rid of the other one.
I can't take away this factor of 8, but I can multiply more numbers in to make it 8. Okay. Second fraction has a factor of 5. Is that represented in my LCD right now?
No.
No. Usually with numbers, I'll put them on front here. So there's a 5, and it has a factor of x plus 1. Is that in my LCD?
No.
No. So I need to multiply that in.
And then wouldn't that get rid of, you already got rid of everything on the other one?
Okay, just let me see, please. Okay. Everybody good with this so far?
Yep.
All right. Third fraction. Do I already have a factor of x plus 1?
Yeah.
Yes, so don't multiply another one in. Then it's not a least common multiple anymore. Okay. X minus 1?
Yeah.
Already had that factor, so there's your LCD. A little bit easier, honestly, with like ones where you have to factor. Okay. Let me give it a try one.
Are you finishing this today?
No.
What about the numbers on the top?
Oh, we just had to find the LCD.
Yeah, come on.
We just had to find the LCD. Yeah. Now we'll actually get to adding and subtracting some. Now, first of all, I didn't put any of like this in the notes, but if you already have common denominators, you don't have to write this down. But if you already have something like this, how would I do this? Just like fractions. Add the top. What would my denominator be? Stay the same. And then we want to simplify this.
8, 6.
Okay. All right. So don't let the variables throw you off. If they're already common, you know how to do that. Here, do I have the same denominators? Unfortunately not. All right, so we got to factor the denominators in order to find our LCD. But that's like the first thing we want to do is like identify the LCD, and I always just like to jot it off to the side here. So I'm going to factor both my denominators. Now 6x squared is just a monomial. It's just one term. Not really much you can do there to factor it. Okay, kind of like those ones we did yesterday. This denominator over here, what can I factor out? 4x, and I'd be left with x minus 3, and that's fully factored. Okay. Don't overthink the number part of this, guys. You guys know what's the least common multiple of 6 and 4? Multiple. 12, right? Just as if, hey, we did one like that on the warm-up, wasn't it? Where there was a 6 and 4 in the denominator? Yep. All right, so for the numbers, and again, if you want to break it down as like I was doing, 3 times 2, 2 times 2, so I need a 3 times 2, and I need a 2 times 2 in there. There's your 12, okay? If you need to do that, you can. But also, don't overthink it. You guys know how to find LCDs with 6 and 4. That'd be 12. So starting with my first denominator with the variables piece. This one has 2 factors of x, right? So that has to be my LCD. Second denominator. I already took care of the 4 with the 12. Has a factor of x. Is that already in my LCD?
Yeah.
Do I need to multiply another one in?
No.
No. Has a factor of x minus 3. Is that in my LCD? No. So I need to do this. Okay, there's your LCD. Got it? All right, so I'm going to rewrite these fractions. And I want you to give yourself a little space in between each. So do this. Let's write it in the factored form. 4x. Yeah. Okay. There are my 2 fractions that I started with in factored form. Let's revisit what I would do if these were numbers. Like, look at this one. After I found the LCD of 30, I multiplied each fraction on top and bottom by whatever factor they were missing from 30. Right? And again, these numbers, you've done this for so long that you don't really think of it that way. But here you started with a 3, you wanted to get to 30, so you multiplied by the factor that was missing from 30. So here, I'm going to do this in red. Here I need to multiply the top and bottom by whatever I'm missing from the LCD. All right? So I have a 6. What do I need to get to 12? 2. I have the x squared already, so I don't need to multiply by an x squared. What else do I need? I need the x minus 3. So this fraction I would times by 2 times x minus 3, and whatever you do to the top, you got to do to the, or whatever you do to the bottom, I should say. Whatever you do to the bottom, you got to do the top because you're really just multiplying by a 1. So right now, folks, what I'm trying to do is I'm making equivalent fractions. Okay? So what happens with that fraction, I'm not technically done with this second step, but what happens with that fraction is now I get 6 times 2, I get 12 x squared times x minus 3 in my denominator, and that's what I wanted. I wanted to get my LCD. Maybe I'll do this one blue. Everybody see that?
Yeah.
That I get 12 x squared times x minus 3. And then we might as well, while we're here, let's multiply the numerators together. So there's 2 ways you can do this. It's 10 times x minus 3. If you want to distribute that all in one step, you can. We will have to eventually. But hang tight. Okay. Second fraction.
3x.
I need to multiply the top and bottom by what I'm missing. So Wesley says 3x. Do we agree?
Yeah.
And if you're not sure, obviously you're going to have to do the multiplication in the next step. So you can check, would the 4x times the 3x, would that give me my LCD? 12x squared. Yes, it would. What would I get in my numerator? 3x squared. Good. Okay, so here's me making equivalent fractions. You know you did this right if you have the LCD on both your fractions. Let me ask you this question. Do you think we want to cancel these out? It's really tempting.
Yeah, no.
I was saying that we should, but no.
No, because then it's not the same as the other one.
Exactly. We're trying to get these to be the same, right? A lot of students will do this mistake. they'll like get to here and they're like, oh, cancel. I'm like, whoa, you just multiplied it in. We want it there, right? We want our denominator to have that. And eventually we're going to have to add the numerators together, so you will have to distribute your numerators through, but your denominators you can keep in this factored form. So now we're ready to add these together. I'd probably do this first. I'd probably write that as 10x minus 30 over my LCD. So the numerators you will have to multiply through, but the denominators, since I don't have to add denominators together, since they stay the same, you can keep them in the factored form, and then it's one less step you have to do in the end to simplify it because they're already factored. Okay, we're ready to add, my friends.
We have to do AC.
How do I add? No, not this time. How do I add fractions? I add the numerator, so I'm going to write this in standard form. I'm going to put that 3x squared first. That gives me 3x squared plus 10x minus 30 all over
12x.
12x squared. Yep, and don't multiply this through. Times x minus 3, that'd be your final answer. Now,
Cool.
you should check if the top factors. I don't think it does.
Huh?
You should check if the top factors, like you'd have to try AC method, because it might be able to be simplified. But if you find the LCD, if you find the least, your answer should come out simplified. Okay? Sometimes people will just like straight up just multiply the denominators together, and then you're gonna get a large like polynomial in your numerator that you have to try and factor and all that jazz. But it could happen, folks, especially on the ones where they already make common denominators for you. Remember that one I wrote on the board, how we got like 16 eighths and then, or whatever it was, 16 fourths or something. We had to reduce it at the end. You should check if you can simplify this. This one, I'm telling you right now, it doesn't simplify. Okay, let's try another one. That wasn't too bad, right?
Yeah, horrible.
Just a little bit more steps than multiplying and dividing. All right, number 2. Factor first. Let's factor the denominators. This one's nice and easy. That's x plus 2 times x plus 2. This one, difference of squares, x plus 2, x minus 2. All right, anybody want to try and come up with the LCD? Connor?
X plus 2 squared, x minus 2.
Ooh, I love how you said that. X plus 2 squared. Obviously, I have these two factors. And then coming over to my second fraction, I do need a factor of x minus 2. Okay, good. So here's what I currently have. I have x plus 1 over, I'm going to write it in that factor form, x plus 2 squared minus two over x plus 2 times x minus 2. Here's what I have. So in red, I'm going to make my equivalent fractions, aka I'm going to multiply the top and bottom to each fraction by what they're missing. This one's missing the x minus 2. What's my second fraction missing? X plus 2. Good. Bless you. All right. Now, before I go through all the hassle of multiplying out my numerators, let me just quick check and make sure my denominators give me that LCD. So my first fraction here, obviously I get that x plus 2 squared times that x minus 2, and that is indeed, that's my LCD. Okay, that one looks good. Let's check the second one. Here I see x plus 2 times x minus 2 times x plus 2, so I could write that in the same way. And it helps if you do write them in the same order, because then you can clearly see the common denominators. Okay, you guys did a good job. We figured it out. Now up top, we do have to multiply these together. So be careful with this math here. You have x plus 1 times x plus 2. So you got to FOIL it out or distribute it out. That's x squared minus 2x plus 1x is minus x minus 2. The reason why I'm multiplying out the numerators and not the denominators is because in the adding and subtracting fractions, we actually have to add or subtract the numerators together and not the denominators. All right? All right, here I got to do 2 times x plus 2, so that's 2x plus 4. Everybody good? All right. Do we have the same denominators?
Uh-huh.
Okay, now we're ready to subtract them. Careful here. When you're subtracting fractions, you're subtracting everything in the numerator. So if it helps you to change this to plus the opposite, you can do that, but you have to remember to subtract the 2 and subtract the 4. All right, so we'll actually get a final answer here. Let's do this in standard form. I have x squared. So negative x minus 2x is minus 3x, or you can think plus negative 2. Negative 2 minus 4, negative 6. All over. Keep the denominators the same. This one I know for sure does not factor. There's not two numbers that multiply to negative 6 and add to negative 3. So that's my final answer. I like doing these. I think they're so fun.
I know.
Are you guys ready to do the 3 fractions together?
No. Can we do it tomorrow?
Thank you so much for asking. The answer is no. Okay. Let's try one with 3 fractions. The nice thing is, look at my denominators. They're all factored for me.
Yay.
That's nice. I don't have to do any factoring. So when I'm jotting down my LCD here, this denominator is a factor of x plus 1. This one has a factor of 2x minus 3. This one has a factor of x. Do I need to multiply in another x?
Yeah.
But I have one right here.
Well, that's x plus 1.
Yes, it's not a factor of x. That's a factor of x plus 1. So yes, we do need another x. I typically like to put it in front like this. You don't have to, but it's easier to see it that way. All right, there's my LCD. Boy. Notice how I gave you a whole half a page for this problem?
Yeah.
You're welcome. All right, so right now I'm just jotting down what I have already in the problem. And then in red, I'm going to times the top and bottom by what each fraction is missing from the LCD in order to make an equivalent fraction that contains my least common denominator, just like with fractions. All right, what do I need to multiply my first fraction by?
2x minus 3.
X
X
to
is
it.
2, but
Yep, 2x minus 3 and x. Good.
Could you do 2x cubed minus 3x?
Yeah, you could, but don't do that in your denominator. In our denominator, we want to keep it like in that factored form. But in your numerator, you could. All right, what's my second fraction missing?
x plus 1 and x.
Good. Factor of x plus 1 and x. What about this one?
X plus 1, 2x minus 2.
Oh boy, that one we got a lot of multiplying to do. Okay. Before I go through all the work of multiplying my numerators, I'm just going to check and see if we get the same denominators in these 3 fractions. So here I have x times x plus 1 times 2x plus 3. I'm going to reorder it. Sorry, 2x minus 3. Okay, that looks good. I got my LCD there. Here, x times x plus 1 times 2x minus 3. Check. Got my LCD there. Third one, x times x plus 1 times 2x minus 3. Check. Okay, we're good. We multiply by the correct stuff because I can now see all my denominators are the same or are common. Now we actually have to multiply with the numerators. Whoa. And again, we don't want to multiply with the denominators, but the numerators we have to because we have to add and subtract all those terms together. All right. So I would, in this one, treat this as 4x squared times 2x minus 3. Like multiply those together first and then distribute. So you get 8x cubed minus 12x squared. Or you could do what Connor said, like you could distribute that x through if you want and then times that by 4x. Here I would do 5 times x plus 1. So second fraction, I'd get 5x squared plus 5x in the numerator. Good?
Yeah.
All right, this one, I'd probably multiply these together first. And then distribute the 4 through. Okay, so we got 2x squared. Let's see. Minus 3x plus 2x is minus x minus 3. And then let's multiply the 4 through. So 8x squared minus 4x minus 12. All right, everything's looking good. Think we're ready to combine our fractions? I think so too. We have all the common denominators. All our numerators are all nice and multiplied out, ready to be added together. Denominator stays the same. All right, I see that subtraction, and I know I'm forgetful, so I'm going to change those all to plus the opposite. All right, so writing my numerator in standard form. Looks like I only have one x cubed term. And it helps you guys. You can kind of like cross them off as you combine them. X squared terms. I have negative 12, 5, and negative 8 for a total of what? Negative 15 x squared. Good job. X's, I have 5 and 4. So you get 9. And then I just have that plus 12.
Okay.
Not too bad, right, my friends?
Now we're done, right?
Yeah, we can stop there.
Do we only have one assignment? Please, do we only have one assignment?
There is one ALG assignment,
Oh my goodness.
and there's one worksheet that's just on the complex fraction stuff. So I'll wait to give that to you
There's no
tomorrow.
book assignment?
No book
I'm
assignment.
crying right now.
Oh, thank the Lord.
No
No.
book assignment for
Oh,
this
this
one.
is gonna suck.
No, Alex does not suck.
It will.
It does.
My pre-code